Hi, good day to ladies and gentlemen. Today we are going to learn chapter number 9, Fit and Tolerances. And this lecture 9 was prepared based on module learning outcome number 2, which is a generate two-dimensional engineering drawing of part and assembly models. What is tolerance? It means allowance for a specific variations in the size and geometry of part. Tolerances are used by engineers to control the allowance for a specific variations inherent in all manufacture of part. Large tolerance may affect functionality of the part. Example, unable to mate in an assembly. And small tolerance may cause high costing of the part. Example, require high precision manufacturing. And why tolerance is important? In assemblies, parts will often not fit together if their dimensions do not fall within a certain range of values. Interchangeability. If a replacement part is used, it must be duplicate of the original part within certain limits of deviations. The relationship between functionality and size of the shape of an object varies from part to part. An example of engineering component require a high tolerance, such as a gear inside the gearbox. Actually, it requires a very high tolerance. Okay, tolerances. Okay, what is high limit? It's the largest acceptable size. Low limit is the smallest acceptable size. Tolerance is the difference between high and low limits. Allowance is the smallest difference between the limits of two fitting components. So in this case, it's the fitting in between shaft and bearings. So what is largest currents is the combinations of allowance plus tolerance of shaft and tolerance of your hole. Okay, tolerance. Unilateral limits occur when both maximum limit and minimum limit are either above or below the basic size. So by referring to the top figure, the upper limit and lower limit are above the basic size. So how we write the tolerance? We write 5, 25, superscript the tolerance for upper limit and the subscript for lower limit. So which means the upper limit is become 25.18 and lower limit is 25.10 mm. So the tolerance is the difference in between upper limit and lower limit, which is 0.08 mm. So how about the bottom figure? The lower limit and upper limit are below the basic size. So how we write this? Similar. 5, 25 tolerance for the upper limit. We write in superscript negative 0.10 and subscript for the tolerance for lower limit negative 0.20. So the upper limit will become 24.90 and lower limit will become 24.80. So the tolerance is the difference. So it will become 0.10 mm. So for unilateral limits, a case may occur when one of the limits coincides with the basic size. So example, in this case, the 525, the tolerance for upper limit is 0.2, while the tolerance for lower limit is 0. Right? So bilateral limits occur when the maximum limit is above and the minimum limit is below the basic size, which means your basic size fall within the range in upper limit and lower limit. So for example, 525 superscript plus minus 0.04. So the upper limit will become 25.04 and lower limit will become 24.96. So the tolerance is 0.08. So fits. When two components have to be assembled together, such as bearing and a shaft, the difference in size determines the class of fit. So there are three different types of fit. Difference, which is currents, transitions and interference. So we refer the top figure, we ignore the bottom figure, this three figure at the bottom we just ignore. Okay, what is currents? The shaft is smaller than the hole. And interference, the shaft is bigger than the hole. And transition is the shaft is slightly bigger than the hole. Okay. So how we fit the currents fit? It's free running fit. Okay, you don't need to do anything. Just place the shaft on the hole you put inside. If you're free running. Okay. How about transition fit? Transition fits, we need to use push fit by your hand. We need to apply a small amount of force to make the shaft put inside the bearing, because the shaft is slightly bigger than the hole. Okay, so the shaft may be up to 0.01 mm larger than the hole, or as much as 0.016 smaller than the hole. So in this case, we can use a light press fit to fit the shaft inside the bearing. How about interference fit? In this case, we need to use an external force, or the force from a press or machine, to force the shaft to fit inside the bearing. So British standard limits and fits. So it's a government's limits and fits used for hole and shaft in industry. Tolerance positions letters, capital for hole and lowercase for shaft. So make sure you use a capital letter for the hole or bearing and small letter for shaft. Okay, what is nominal diameter? Is the diameter in between the inner diameter and outer diameter. So actually there's a ISO standard in limits and fits. So there are symbol D, E, F, G, H. A to G, capital letter A to G is a positive for holes and negative for shaft. And the letters after H, negative for holes and positive for shaft. Okay, by referring to this table, let's say we want to have a current fit for H8 for hose and F7 for shaft. So we look at the example. This one. H8 is for hole and F7 is for the shaft. This is how we do the current fit according to the table. So the 40 here for the hole means is their basic size, and HS is the tolerance grade. And for the shaft, 40 is the basic size, and F7 is the tolerance grade. So this is the graph for ISO standard in limits and fits. So this is another example. This is a standard hole basics table and limits. And actually there are guidelines of ISO system in limits and fits. You can go through the descriptions one by one. I think that's all for the lecture for today. Okay, thank you very much and see you next time.